In a Chicago machine shop, an engineer places a dial indicator on a 1947 Monarch lathe, 2 microns. Beside it, an 8-year-old German CNC awaits the scrapyard. The ancient machine just embarrassed the future, and nobody wants to admit why. There are 360 degrees in a circle, but only 0.00008 inches of error on that Monarch spindle. That's 2 microns, the width of a single bacterial cell. For 77 years, this machine has held tolerances that would make a modern aerospace engineer weep. Meanwhile, the CNC next to it, purchased for $500,000 in 2017, now drifts 15 microns under load. It's headed for the landfill while its grandfather keeps cutting titanium parts for satellites. This isn't survivor bias. This isn't nostalgia. This is physics, economics, and a conspiracy of obsolescence that rewrote the rules of progress itself. The uncomfortable question nobody in manufacturing wants to answer is this: if we could build eternal machines in 1940, machines that would outlive their operators and their operators' grandchildren, why did we stop? And the even more disturbing follow-up: what else have we forgotten how to make in the name of quarterly earnings? The Monarch Machine Tool Company operated out of Sydney, Ohio, building precision lathes during an era we've largely written off as technologically primitive. No computers, no CAD software, no finite element analysis. Just slide rules, micrometers, and an almost religious devotion to a process that modern business schools would call criminally inefficient. These machines built parts for jet engines when jet engines were still experimental. They cut surgical instruments before stainless steel was standardized. They machined submarine components during a war that demanded perfection because imperfection meant death. The men who built these machines are mostly gone now, their names lost to history, but their work remains. In shops across America, across the world, these cast iron cathedrals still operate daily, holding tolerances that would have been considered impossible when they were new. They've outlasted the companies that built them. They've outlasted the technologies that replaced them. They've outlasted the very philosophy that created them. And here's what should terrify us: they did it with 3 secrets that modern manufacturing has deliberately abandoned. The first secret sounds absurd to anyone trained in just-in-time manufacturing, lean production, or inventory optimization. It's a secret that would make a modern CFO physically ill. The iron had to age like wine for years. Behind the Monarch factory in Ohio, there existed what old-timers called the curing yards. Open fields where massive cast iron blocks sat exposed to the elements for 1 to 3 years before they were ever touched by a cutting tool. Rain fell on them. Snow buried them. Summer sun baked them. Winter frost penetrated them. They weren't forgotten. They weren't neglected. They were transforming. When iron is cast, when molten metal solidifies in a mold, it freezes with internal tensions locked inside its crystalline structure. Molecules that cooled at different rates pull against each other like tectonic plates. Left alone, these tensions will express themselves over time. The block will warp. It will twist. It will move in ways so subtle you can't see them, but so catastrophic that a 10,000th of an inch becomes a quarter inch over a decade. The curing process was molecular therapy. As seasons cycled, the iron expanded and contracted. Summer heat made it grow. Winter cold made it shrink. Spring humidity penetrated its pores. These thermal cycles, repeated hundreds of times, allowed the internal stresses to bleed out slowly, naturally, permanently. The crystal structure reorganized itself at the atomic level, finding equilibrium not through force, but through patience. This wasn't superstition. This was material science before anyone called it that. The old craftsmen understood something that modern engineers have to relearn through failure. Iron has memory. It remembers how it was born. And if you don't give it time to forget the trauma of casting, it will spend its entire service life trying to return to its molten state. Modern machine tool builders use what the industry calls green iron. Cast today, machine tomorrow, sold next month. The financial logic is impeccable. 3 years of iron sitting in a field is 3 years of capital doing nothing, earning nothing, justifying nothing on a spreadsheet. Inventory is cost, time is money, efficiency is God. But here's the cost they don't put on the spreadsheet. A CNC machining center with a green iron base will warp 0.003 inches over 5 years. That's 3/1000ths. In precision machining, that's apocalyptic. That's the difference between aerospace tolerance and scrap metal. And the machine doesn't tell you it's happening. It just slowly, quietly, expensively becomes a very heavy paperweight. Meanwhile, that 1944 Monarch, the one that sat in a field in Ohio for 30 months before anyone touched it, still holds .0001-inch tolerances, 1/10 of 1,000th, after 80 years. Because someone understood that you cannot cheat physics, you can only choose whether to pay the price in time or in failure. The evidence is overwhelming and ignored. Original Monarch 10EE lathes from World War II routinely hold tenths. Modern manufacturers warranty their machines for 1 year. 1 year. Then it's your problem. They know what's coming. The warranty expires right before the iron starts moving. But aged iron was only the foundation. The real magic happened in the second secret. The one that required not just time, but masters. Men who learned their trade through apprenticeships that lasted longer than most people stay at a job today. The art of fire and grind. Induction tempering was performed by craftsmen who read metal the way sommeliers read wine. They would heat the machine's bedways, the critical surfaces where the carriage slides, section by section using induction coils. No thermocouples, no digital controllers, no computer monitoring. Just human eyes watching the metal change color from cold gray to salmon pink to cherry red. Each color represented a temperature. Each temperature represented a crystalline transformation happening inside the steel. Too cold, and the surface wouldn't harden. Too hot and thermal shock would warp everything the curing process had stabilized. These men spent 30, 40, 50 years learning to see heat. They knew that cherry red looks different in direct sunlight than in shade. They knew that thick sections hold heat longer than thin ones. They knew that the coil position mattered, that the heating rate mattered, that everything mattered. They were inducing a phase transformation in the iron surface, creating a layer of hardness, 58 to 62 on the Rockwell scale, while preserving a tough, resilient core beneath. This combination meant the surface would resist wear forever, while the body would absorb shock and vibration without cracking. Modern heat treatment uses computer-controlled furnaces, precise temperatures, exact timing, perfect repeatability, and it creates residual stresses that the old method avoided because gradual heating that responded to the specific piece of metal in front of you rather than a programmed recipe, prevented thermal shock. The masters weren't guessing. They were feeling. And feeling, it turns out, is a precision instrument that we threw away. After tempering came the art that almost nobody practices anymore: hand scraping. If tempering was science disguised as intuition, scraping was meditation disguised as manufacturing. A machinist would take a simple carbide scraper, a tool that looked like a chisel with a hooked edge, and begin removing .0001 inches of material per stroke across a bedway that might be 6 feet long and 8 inches wide. The process was simple in description and impossibly difficult in execution. Coat a precision reference surface with Prussian blue dye. Press it against the workpiece. The high spots take the dye. Scrape those spots. Repeat for 40 hours, 80 hours, 120 hours, until the bedway makes contact with the reference surface at 20 points per square inch or more. That's molecular level flatness. That's a surface so true that oil trapped between it and the carriage doesn't just lubricate. It forms a hydraulic barrier that makes friction almost theoretical. The old masters had a saying: you don't scrape until it's flat. You scrape until the iron sings. They could hear it, feel it in their hands when the surface achieved a state of perfection that no measurement tool could fully capture. Modern shops call this scraping, but few do it. CNC grinding is faster, and faster is profitable. But grinding induces stresses. Grinding creates heat. Grinding is violence compared to scraping's conversation. The difference shows up a decade later when the ground surface has degraded and the scraped surface is still perfect. And modern manufacturers didn't just abandon scraping for bedways. They abandoned cast iron bedways entirely. Welded steel fabrications are lighter, easier to ship, faster to produce, and catastrophically inferior. Welded structures have heat-affected zones around every bead, places where the metal's grain structure was disrupted, where stresses concentrate, where cracks want to start. These structures ring like bells when you cut metal on them. The vibration that should be damped is instead amplified, transmitted back into the cutting tool, degrading surface finish and accelerating wear. Cast iron, especially cast iron that weighs 4 tons, doesn't ring. It thuds. It absorbs vibration like acoustic foam absorbs sound. This is about natural frequency. Every structure vibrates at specific frequencies based on its mass, stiffness, and geometry. Machine tools generate vibrations when cutting. If the machine's natural frequency is close to the cutting frequency, resonance occurs. Amplification, chatter, ruined parts and broken tools. Massive cast iron bases push natural frequencies so far away from cutting frequencies that resonance becomes impossible. But shipping 4 tons of iron costs money. Storing it costs money. Modern engineering decided that lightweight was worth the compromise. They were wrong, but the parts fail in the customer's shop, not in the sales brochure. The third secret wasn't even really a secret, it was philosophy. Monarch designed for eternity, and eternity requires simplicity. Manual oilers instead of automated lubrication systems. Not because automation hadn't been invented, but because every automated system is a failure point waiting to happen. The daily ritual of greasing each bearing, oiling each way, meant the machinist developed intimate knowledge of the machine. You noticed when a handle felt different. You heard when a bearing started to whisper its distress. You caught problems when they were whispers, not screams. Modern CNCs have automated lubrication systems that fail 7 years in. The pump quits, the lines clog, the sensors lie. By the time the operator notices, bearings are damaged. And those bearings? Pressed in, proprietary sizes. Discontinued because the manufacturer wants you to buy a new machine. Monarch used standard taper roller bearings. Any bearing supply house in America stocks them. You can replace them with hand tools and a bearing puller. The electronics tell the real story, though. A Monarch has no electronics, no circuit boards, no control processors, no proprietary software. When something breaks, and everything breaks eventually, a competent machinist can fix it. Cut a new gear, rewind a motor, scrape a worn bearing surface. The knowledge required exists in books, in the hands of old-timers, in the fundamental mechanical engineering that hasn't changed since Archimedes. A modern CNC dies when its controller dies, and controllers die in a decade. The manufacturer discontinues support. The replacement parts disappear. The software becomes incompatible with newer operating systems. The machine, mechanically sound, becomes electronic waste because a $15 chip failed and nobody makes that chip anymore. This isn't accidental. This is business model. The conspiracy isn't hidden. It's taught in business schools. Planned obsolescence went from shameful practice to strategic imperative sometime in the 1950s. The post-war boom taught manufacturers a terrifying lesson. If you build products that last forever, you only sell each customer once. That's not a business. That's a going out of business plan. So they engineered failure. Not catastrophic failure that would anger customers, but timed degradation. Things that work beautifully for 7 years, acceptably for 3 more, then fall apart right when the economic pain of constant repair exceeds the pain of replacement. Machine tools followed this pattern precisely. The marketing shifted from buy it for life to life cycle management. Corporate doublespeak for we've optimized the failure point to maximize your total spend. Shops that bought one Monarch in 1947 might still be using it. Shops that bought their first CNC in 1999 are on their 4th machine. The iron is still good on those old CNCs. The ways are still true, but the Siemens controller uses software that Windows no longer supports, and the servos require a discontinued amplifier board, and suddenly you're shopping again. Meanwhile, Monarch parts diagrams from 1947 still work. The drawings still make sense. The tolerances are still achievable. A machinist in 2025 can fabricate replacement parts that will fit perfectly because the machine was designed with human-scale repairability. No proprietary lockouts, no encrypted firmware, no planned death, just mechanical honesty. The financial impact is staggering when you actually calculate lifetime cost. A shop owner in Milwaukee bought 3 CNCs between 2000 and 2020. Total investment including installation, tooling, and training, $1.4 million. His competitor bought a rebuilt 1952 Monarch in 1995 for $18,000. Spent another $12,000 over 25 years on maintenance, still using it today. The economic argument for disposable precision is a lie that only works if you calculate in quarters instead of generations. The environmental cost is worse. Every landfill in America's industrial regions has a corner filled with 10-year-old machining centers. Tons of steel and iron, circuit boards laced with rare earth elements, hydraulic oil contaminating soil, all because a controller died. The green movement talks about light bulbs and grocery bags, while precision manufacturing throws away buildings full of equipment that could have lasted centuries. A Monarch scrap today is a tragedy. A CNC scrap today is Tuesday. But the deepest loss is cultural. Engineering schools stopped teaching hand scraping in the 1970s. Why teach obsolete skills? Why burden students with ancient knowledge? Now we have a generation of manufacturing engineers who have never seen it done. The last master scrapers are in their 70s and 80s. They're retiring, they're dying, and they're taking with them a body of knowledge that exists nowhere else. You cannot learn to scrape from a textbook. You cannot learn it from a video. You must feel it in your hands, develop the muscle memory, the intuition, the sense of when the iron is beginning to sing. When the last scraper retires, that knowledge doesn't go to a library, it goes to a grave. There's a resistance, though, small but growing. The used market for Monarch 10E lathes is irrational by modern standards. Clean examples sell for more than they cost new. A machine from 1948 commands $20,000, while a used CNC from 2015 might bring $8,000. The market knows something that the MBA programs don't. Longevity has value. Repairability has value. Independence from manufacturer support contracts has value. These old machines are appreciating assets in a world of planned depreciation. Rebuilders have turned scraping into a boutique service. Shops that will take your worn Monarch, strip it to components, rescrape every bearing surface, replace every worn part with newly fabricated pieces made to original specs, and return it to better than new condition for less than a down payment on a new CNC. And YouTube, improbably, is preserving knowledge. Old guys filming themselves scraping, showing the young guys how it's done. Hundreds of thousands of views. 20-year-olds learning skills their professors never heard of. It's a tiny revolution, but it's happening. And some modern manufacturers, the premium ones targeting industries where price is secondary to performance, have quietly reintroduced the old principles. You'll find them in Swiss machining centers costing $300,000. Hand-scraped bedways, aged iron castings, induction-hardened ways. They don't advertise it as going backwards. They call it advanced manufacturing techniques. They rediscovered what Monarch knew in 1940. Mass damps vibration. Time relieves stress. Craftsmanship beats automation for ultimate precision. They're selling 70-year-old technology at premium prices and calling it innovation. The question this raises is philosophical. When is older better? The reflexive modern answer is never. Progress is linear. New improves old. Replacement is advancement. But that's not physics. That's marketing. And the Monarch lathe is physical proof that we sometimes optimize the wrong variables. We optimized for purchase price and forgot about lifetime value. We optimized for shipping weight and forgot about damping. We optimized for assembly speed and forgot about repairability. We optimized for quarterly reports and forgot about generational thinking. Every industry has artifacts like this. Tools, techniques, materials, processes that were abandoned not because they were inferior, but because they were inconvenient to corporate growth models. Sometimes we rediscover them and call it innovation. Sometimes we just keep relearning the same expensive lessons. The warning here isn't that all old things are good. It's that new things aren't automatically better. And when we discard old knowledge without understanding why it worked, we don't just lose techniques. We lose the ability to even recognize what we've lost. If you're a machinist, that old lathe in the corner might be your best asset. If you're an engineer, the assumption that newer is better might be costing you precision. If you're running a shop, life cycle cost analysis might show you've been making expensive mistakes. And if you're young and just learning, find the old guys before they're gone. Learn what they know, not because it's romantic or nostalgic, but because some knowledge only exists in human hands and human memory, and once it's gone forever. The Monarch lathe sitting in that Chicago shop, holding 2 microns of error after 77 years, isn't just a machine. It's evidence. Evidence that we knew how to build things that would outlast empires. Evidence that we chose not to. Evidence that progress isn't always progressive. And evidence that every time we assume the old way is the wrong way, we should at least ask why it worked before we throw it away. Because the CNC beside it, silent and waiting for the scrap truck, cost more than a house. And it couldn't make it a decade. That's not progress. That's not innovation. That's just expensive disposability with a better marketing department. The iron knew better. We just forgot how to listen.